In this lesson, we will solve equations with one variable and solve equations with two variables. The way we'll be solving them is in a little bit different way. So here's some vocabulary to help us out. The first is an open sentence, which is a mathematical sentence that contains an algebraic expression and symbol. So these are going to be equations that have letters in them as well as numbers. An equation is a mathematical sentence that contains an equal sign. So you see this four letters here, equal, so we know it's going to be equal on both sides. Solving the open sentence is finding a replacement value for the variable that results in a true sentence or an ordered pair that results in a true statement when substituted into the equation. We're going to substitute values into an equation to see which ones work, and that's called solving the open sentence. A solution is a replacement value for the variable in an open sentence, so it's basically the one that works. A replacement set is a set of numbers from which the replacements for a variable may be chosen, so these are the numbers you get to pick from. A set is a collection of objects or numbers often shown using braces. I call these brackets, and usually named by a capital letter. An element is each object or number in a set, also called a member. And a solution set is the set of elements from the replacement set that make an open sentence true. And so we'll have brackets around the solution as well. So here's what it'll look like. I have a replacement set here. These are the values we're going to plug in. I have an equation here, and I've set it up a table. So this is where my replacement values will go. This is where I will try it, and this is where I will state whether it works or not, true or false. So 2 times 2 is 4, plus 5, that makes 9. So this is false, because 9 is not equal to 13, and I'm looking for 13. 3 times 2, I wrote that backwards, is 11, and that is false. Here I have 2 times 4 plus 5, which is 13, so this is the true. This one is 13 equals 13. But you may want to stop here, but we do have to go on and check the other replacement values and show whether they work or not. So 2 times 5 plus 5 is going to be 15, which is false. And 2 times 6 plus 5 is going to be 17, which is false. So your solution set would just be the 4 because that is the only value that worked. So we would have a solution set with the 4. In this type of problem, you're going to solve for the variable. So if you'll notice, it's already on the right side by itself. So you just use order of operations. Same thing in this example. You'll do this example in your notes. I'll work this one with you. I start by doing exponents first. Then I do parentheses next. These are both equal to p still. And then I have to divide before I add. So 6 plus 10 is 16. So now we've solved for that variable p. You will do the same on this example in your notes. Now in this type of example, we have a variable on one side, so we are going to have to solve for that variable, but we have to use order of operations to simplify it down. So this would become 16, and then I would do parentheses, so this would be 7 minus 6 plus n, and then I have to subtract. 7 minus 6 is 1. Now you could easily plug and chug to figure out what n would be here, but using inverse operations, I would subtract 1, and I get n equals 9. And then you could plug this back in and see if it works. You'll work this example in your notes. Another vocabulary we have is identity, and it's equation that is true for every value of the variable, so it is going to be something that works out to be always true. So this is a multiplication here, and this is not squared. This 2 is a 2 times. So let's go ahead and use order of operations. Multiply before we subtract here. So this is 10 minus 8 times this whole value, and that would be 2 times this whole value. Now on this side, I'm going to put that 2 out front. And if you'll remember from last time, 2h plus h would be 3h. And I want you to look at something right here. These are the same. They're exactly the same. So that means when I simplify this down further and further, I will get a true statement, something that is always true, like 2 equals 2. That is forever true. So let's go ahead and just distribute to see what happens. This will be 6h plus 12. Look what this is. 6h plus 12. And if I continue working on and on, it'll be exactly the same. And that's what we call identity. The symbol is this. When it's always true, that's called identity. You'll work this example in your notes. All right, our final example today is a real world problem. You will have to do this on your worksheet. Mr. Callan pays $10 each month for movies delivered by mail. He can also rent movies from the Redbox for $1.50 per title. Let's write and solve an equation to find the total amount Mr. Callan spends this month if he rents 3 movies from the Redbox. So let's just have a variable here. Let's have X be the movie. And so he's going to rent 3 movies that would look like this. And then he has to pay for those movies that are delivered by mail. So that's going to be $10 per movie no matter what. So this is an expression that we could use to represent that total. I'll do an example with you tomorrow so you can kind of understand that a little bit more. All right.